Good day, everyone. Today we are presenting our toy collection management system. And before we begin, let me introduce our team. This project was made possible by our dedicated team, with me, Januin Landong, as the leader, along with Mr. APELLIDO, Ms. Arabe, Ms. Coronado, Mr. CUELLAR, Mr. LITRERO, Mr. Manlapas, Mr. Montablan, Mr. Oronan, and last but not the least, Mr. Sarmiento. Now let us proceed with a detailed discussion of its implementation, beginning with the main method. Firstly, we initialize a buffered reader to handle user input, and we also create an instance of two ARABEs, one for storing and managing toys, and the other one for the toys storing interactive features. When the program starts, the system displays the program title. The program continuously displays the main menu until the user chooses to exit, and this is achieved using a do-while loop. Next, a switch statement is used to handle each possible option from the integer input of the user inside a try-catch to handle number format exceptions and repeatedly ask for a valid input. And these options are: 1 is for adding a new toy, 2 is for removing toy by ID, 3 displaying all toys, 4 searching toy by its name, 5 is for filtering toys by its condition, and 6 searching toys by their interactive features, and lastly 7 is for exiting the program. And this each selected option calls a corresponding method to perform their task successfully. Next.
Good day, my name is APELLIDO Genesis. Now that we have discussed the main menu, let's take a closer look at a different method called within the switch statement. First, evaluate toy. The evaluate toy method is responsible for collecting all necessary details about a toy before adding it to the collection. First, we ask the user for toy states. Using the isValidString method to ensure valid input, the value of the name will then be set using a setter method and for other details too. Next, we determine the toy's condition using the evaluate condition method. We then ask for the manufacturer's name, again using the isValidString method. We prompt the user to enter the toy size, which is length, width, and height, with the use of evaluate dimension method. The program then asks for the toy's weight using evaluate weight. Next, we check whether the toy is battery operated using evaluate battery operation method. We then ask if the toy has a sound feature using the evaluate sound feature method. Finally, we collect any interactive features of the toy using evaluate interactive feature method. Once all details are gathered, we create a new toy object and return it using the setter method to set the value for each detail. Now let's take a closer look at the evaluate condition method, which ensures that toy's condition is properly recorded. The program displays three options for the user to choose as from, which is new, use, and refurbish. The program reads the user input and processes it inside the while loop. A switch statement is used to assign the corresponding condition based on the user's input. If the user enters an invalid option, an error message is displayed, and they are prompted to try again. If a non-numeric input is entered, an exception is caught and handled. Ms. Arabe will now present on evaluation dimension.
Dangal greetings, I am Merjo L. Arabe and I will explain the evaluate dimension method and evaluate weight method. Evaluate dimension. This method takes a specific dimension, either length, width, or height as a parameter. It continuously prompts the user per input until a valid positive number is provided. If the user enters an invalid value, such as negative number or a non-numeric character, an error message is displayed and the prompt repeats. Another method is the evaluate weight. When prompted, you will need to enter a weight in grams. It ensures that only positive numeric values are accepted, similar to evaluate dimension method. If an invalid input is detected, such as negative values or letters, an error message appears prompting you to try again. The next method will be explained by Jessa Coronado.
Good day, my name is Jessa Coronado and I am assigned to explain the methods evaluate battery operation and evaluate sound operation. Moving on to the evaluate battery operation method, this method returns a boolean that determines if a toy requires batteries to function. It also ensures it also ensures that the user provides a valid response before proceeding. First, the user is asked if the toy is battery operated, with options 1 for yes or option 2 for no. Then, if the user selects 1, the method returns true, meaning the toy requires batteries. Otherwise, if the user selects 2, the method returns false, meaning the toy does not require batteries. Now, if the user enters an invalid input, an error message is displayed and they are asked to enter a valid option. Finally, a loop ensures that the question is repeatedly asked until a correct response is given. Next is the evaluate sound feature. Similar to battery evaluation, this method returns a boolean and determines whether a toy has built-in sound features. It also ensures valid user input. When called, the user is asked if the toy has sound features, with options 1 for yes or option 2 for no. Next, if the user selects 1, the method returns true, indicating the toy has sound features. Otherwise, if the user selects 2, the method returns false, meaning the toy does not have sound features. Now, if the user enters an invalid response, an error message is displayed. Lastly, the program loops until a valid input is received, ensuring only correct values are accepted. Next, Mr. Collier will now present evaluate interactive feature method.
Good day everyone. My name is Brian T. Guelyar, and now let's talk about the Evaluate Interactive Feature method. This method allows the user to select interactive features for a toy. It provides three options for the user: single, multiple, and none. If the user selects single, the program displays a list of available features such as voice recognition and touch sensitivity. The user can either choose one of the predefined options or select custom to enter a new feature. If the user selects custom, the program calls the isValidString method to ensure they provide a valid feature name. Additionally, this custom feature is saved and added to the list of available options, so it will appear as a selectable choice when adding another toy in the future. On the other hand, if the user selects multiple, they first specify how many features they want to add. Just like with the single option, the user can also select custom in this option. If they do, the program allows them to enter a custom feature name. The program then shows the list of available options and prompts the user to select features one by one. Each selected feature is added to the toy interactive features list. Furthermore, to ensure the user enters valid input, this method uses a while loop and a try-catch block. This way, the program continuously prompts the user until they provide a valid selection. If the user enters an invalid input, the program catches the error and asks them to try again. This approach prevents any crashes and ensures that only correct and valid inputs are processed. Once the user has finished selecting their features, the method returns toy interactive features list. This list contains all the features the user chose, and it can be used in other parts of the program to assign the selected features to the toy. Next, the isValidString is a method that guarantees users to not enter an empty string value. It takes a specific detail as a string parameter to prompt the user for input. If the user provides an empty or white space only input, an error message is displayed, and they are prompted again until a valid string is entered. The method then returns the valid input. The next presenter is Mr. Litrero.
And I'm John Patrick M. LITRERO, introducing our toy class. Now that we've covered the main class and how it handles user interactions, let's move on to the toy class. This class defines the structure of each toy object, including its attributes, constructors, and methods for managing toy data. Let's start with how we structure our toy class by defining the attributes. First, each toy has specific attributes stored in private fields. These include an ID, name, condition, manufacturer, size, weight, and interactive properties, like is battery operated, has sound feature, and interactive features. Second, the ID is unique for each toy and is assigned automatically using a static counter, which is the ID counter. In creating a new toy object, we decided to create appropriate constructors to handle assigning the correct values for the toy. First, the default constructor initializes a toy with empty or default values, ensuring that a toy object can still be created even if no details are provided. Second, the ID is automatically generated